So in this session or in this video, we are going to discuss the JEE Advanced Paper 1 of the chemistry. So let's see the questions. So this is the question number 1, in which they have given ideal gas. So in which they given ideal gas, number of moles of ideal gas, it is given 0.5. So initially it is at the 2 bar. Okay, they are compressed at the constant temperature of 600. Okay, so let me write down whatever they have given. So there is a ideal gas. Let's suppose here it is ideal gas whose number of moles are 0.5. Pressure it is given 2 bar. Temperature it is 600 Kelvin. They compress this gas into the 2 steps. Okay. In first, that is against the constant external pressure of P bar, which range from 2 to 8, and then against the constant external pressure of 8 bar. Okay, they done this compression into the 2 different steps. So in first step, okay, let me write it down like this way. So step number 1, so they done the compression. So this is the initially. So if they done the compression, let's suppose here. So they done the compression. So now P external, that is equals to P, whose range is 2 to 8. Okay. And in second step again, they compress this further. They further compress this. So in this case, P external value it is given, that is 8. So P external value it is 8 only. Okay. At each step, the compression is stopped only when the pressure of gas become equals to the external pressure. Means this compression will be stopped only if the pressure of gas will be equals to the external pressure. So in this case, let me take the initial pressure was, so this is a Pi, initial pressure was a 2. So final pressure will be equals to P because it will be equals to external pressure. Then it will be stopped. So in second case, P initial will be equals to P. So P final will be equals to 8 because it will be stopped only if the pressure of gas will be equals to the external pressure, which is given 8. Okay, let's read next. The total work done, we need to calculate total work done in this step is W. So if this is a W1, this is a W2. So I have to calculate total work done. So if I have to calculate total work done, so how I can calculate total work done? Here. So total work done, W will be equals to W1 plus W2. And I know that this compression is carry on at the constant temperature. So if it is a constant temperature, means this is the isothermal process and this is irreversible process, isothermal irreversible. How to calculate work done? So W1 will be equals to minus P of external, V final minus V initial. Similarly, you can calculate for W2. So W2 will be equals to also minus P external, V final minus V initial. Okay. So volume, let's check volume it is given or not. So volume is not given, but they mention this is the ideal gas. So if they mention it is ideal gas, so simple I know that according to the ideal gas equation, PV is equals to nRT, or V will be equals to nRT by P. So I can put the value of nRT put the value of volume into the equation of the work done. So work done at the step number 1. So external pressure is what? So external pressure, if you remember, it is P only. So volume will be equals to nRT divided by P final. If it is a V final, then it will be V final minus nRT divided by P initial. Similarly, we can calculate in this case. So P external, in this case it is given 8. So V final means nRT divided by P final minus nRT divided by P initial. Okay, I can take nRT common. If I take nRT common, so it is equals to nRT. So minus P if I take an inside, so it will be P by P initial. So P initial value is also given. So let me put the value of P initial here. So P initial value, it is given, that is equals to 2 in step 1 minus P of P final. Okay, next here also I can take common nRT outside. So it is 8 divided by P. P initial in this case is P only minus 8 divided by final, it is also given, that is 8 only. Okay, P external and final is same, so it is 1. So it is N is also given. So number of moles is given, how much number of moles are there. So number of moles are 0.5. So number of moles are 0.5. So number of moles 0.5, temperature is given 600, so it will be equals to 300 R P by 2 minus 1. So W2 is equals to, this is also 300 R 8 by P minus 1. If I add both, so what I will get? So in this case, W will be equals to, adding W1 and W2 will be equals to, simple, I can write down here. So W is equals to W1 plus W2, that is equals to 300 R P by 2 plus 8 by P minus or minus will be minus 2. Okay, now how to calculate the value of P here? Okay, let me read the statement further. So further they are asking that consider the all possible value of P and take the gas constant R, the minimum value of W. So here it is a simple mathematical concept is there, how you can calculate the minima. So how you can calculate the minimum value? You know that if you consider W is the function of pressure. If W is the function of pressure, I can say dW by dP will be equals to what? 300 R 1 by 2 minus 8 by P square. They are asking minimum value. So minimum value, this will be equals to 0. So this is 300 R 1 by 2 minus 8 by P square. So this is a constant value, it cannot be equals to 0. So 1 by 2 minus 8 by P square will be equals to 0. So P square will be equals to 16. So P will be equals to 4. So P value comes out to be 4. So you can put the value of P here. So W will be equals to 300 R 4 divided by 2 plus 8 divided by 4 minus 2. So this is 2 that is equals to 600 R. So let's check my options. So option B, that is a 600 R, it is given. So it was a simple question. So only trick here was the how you can calculate that, how you can solve this P which is given from value 2 to 8. So if you have basic understanding of mathematical portion, you can easily attempt that question. Okay, so let's see the question number 2. Okay, this is a question number 2. What it is given: for the reversible reaction P is in equilibrium with the R at the constant temperature, both forward and backward reaction at the first order elementary reaction. So first order elementary reaction means what? So elementary reaction means order will be equals to the molecularity. Okay. The rate constant, it is given Kf and Kb. Rate constant Kf and Kb given at the time 0. Concentration of R by R is equals to R naught. Concentration of P is equals to 0. At any given time, R and P are the concentration of R and P respectively. Okay, so this is the combined concept of chemical kinetics plus equilibrium. Again, if you have understanding of the concept, within 30 seconds you can able to answer the question. I will tell you. So what they have given, Kf and Kb. So Kb they have taken, which is 4 times of K forward. I know that equilibrium constant is equals to what? Rate of forward, rate of backward. So rate of backward they have given, that is 4 times of. So I can say this is a 4 times of forward, that is equals to 1 by 4. So simple, I can say rate constant is what? So 1 by 4 is equals to concentration of product, concentration of reactant at equilibrium. From here you can see, what do you mean by this? Means the concentration of reactant is 4 times of the concentration of product at the equilibrium. So you can check here. So here it is the equilibrium. At this equilibrium, concentration of reactant and product same, means this is not a character. In this case, concentration of product is a 4, 0.8. Concentration of reactant is 0.2. Means this is product is 4 times that of reactant. Means this is wrong. In this is completely wrong. See what they are showing. They are saying the product concentration is keep on increasing with respect to time, which is ideally not possible. So only option you are left with this. You can see the reactant concentration is 0.8 and product concentration is 0.2. So this is nothing but 4 times of this. You can solve this question by this method also. Or if you actually want to calculate the exact value, you can calculate the exact value also. How you can calculate the exact values? We know that they have given the reaction R is in the equilibrium with the P. Okay, at a time is equals to 0. Initial concentration is given R naught, that is equals to 0. At a time of equilibrium, I am assuming this is X. So this is R naught minus X. The concentration of product and reactant at equilibrium, it is given X by R naught minus X, which is given 1 by R. So what I have to calculate? I have to calculate here R by R naught, P by P naught. Okay. So I have to calculate R by R naught and P by R naught. P by R naught. What is P at equilibrium? Or means I have to calculate X by R naught. R is what? Means I need to calculate R naught minus X by R naught. So how we can calculate? You can see this. How we can calculate? If I take it reverse, so what it will be? R naught minus X divided by X will be equals to 4. So it is R naught divided by X minus 1 will be equals to 4. So that is R naught by X will be equals to 5. Means X by R naught will be equals to 1 by 5. That is equals to 1 by 5. From here I can say X will be equals to R naught by 5 also. Okay. I need to calculate this value. R naught minus X, R naught. Okay. So here this is given. Here I can put the value of X. If I put the value of X, what it will be? If I put the value of X, so it is R naught minus X divided by R naught. So divided by 5, that is equals to 4. So if you do this way, then it will be equals to, means R naught minus sets divided by R naught will be equals to 4 by 5. So if it is a 4 by 5, you know that if you do the calculation, it will become 0.8. So this will be become 0.2, which is again 4 times of the concentration of reactant. So simple, we can say our option C is the correct answer. So either you can do, you can able to answer this question in this shortcut way, or you can able to solve this completely, complete the value of R by R naught and P by R naught. Okay, next question. Okay, this is another question. So again, it is a simple question. 2s and 2p orbitals energy of hydrogen atom, means this question is from the atomic structure. So 2s and 2p orbital energy hydrogen atom, energy of hydrogen atom, you remember. So for hydrogen atom means for single electron system, energy is depend upon the principal quantum number, means the value of n. So they have given 2s and 2p, both are same, means 2s will be equals to 2p, the energy of 2s orbital will be equals to 2p orbital, because it is a single electron system. Okay, next read this. 2s and 2p orbital energy of lithium. So lithium, I know that lithium, it is a multi-electron system. So for multi-electron system, energy depend upon the value of n plus l. So 2s and 2p. So 2 and 0, 2 plus 0 will be equals to 2. 2 plus 1, 3, means energy of 2s orbital is less than that of energy of 2p orbital. Okay. So the correct options about the orbital is and are, means it can be a multiple correct answers. So let's see option number A. So 2s is less than that of 2p, that is correct. 2s of hydrogen will be equals to 2p, that is correct. Okay, next they comparing with the lithium with the hydrogen now. So how we can compare lithium with the hydrogen? Okay, one formula we know that. So energy, it is directly proportional to minus of z effective power 2 or n power 2. I know that in case of lithium, z value will be more, energy will be more negative, means magnitude of energy will be less. So yes, they have given the energy of 2s of lithium is less than that of hydrogen, that is also correct. In this case, they are saying 2p and 2s, 2p of hydrogen and either it is 2p or 2s, both having same. So 2s will be having the greater energy. So this is a wrong. So option A, B and D is the correct. I hope you people have answered this question correctly. So next question. Okay, in this question also, what they have given, it's a very simple question. So two cylinder both fitted with the frictionless pistons are filled with a mixture of helium and argon. Okay, let me make that two cylinders. So two cylinders are there. So this is a cylinder number 1. So here you have a frictionless piston mixed with the helium and argon. This is a helium, this is a argon. Helium, in first cylinder, the mass of helium, okay, the helium mass is m1, argon mass is m2. In the second cylinder, the mass of helium and argon, okay. So let me take second cylinder here. In this case also you have a helium and argon. Okay, they just see the in second cylinder, mass of helium and argon is, okay, this is m2, this is m1. So molecular mass of argon is 10 times of that we know that. So molecular weight of argon, it is a 40. Molecular weight of helium, it is a 4. Obviously it is a 10 times of this. Nothing new. The external pressure applied by the piston in the first cylinder needed to be 5 times than that of the second. Means here you have supplying some pressure, here also some pressure is there, but this is a 5 times that of pressure of the cylinder number 2. So that the volume of gaseous mixtures are equals, means volume in both cylinder are equal. Next, temperature. Temperature is also they have given same. Assuming that helium and argon behave like an ideal gas. If they are behaving as a ideal gas, so how simply you can solve this question? Everything it is given. So you have to calculate the value of M1 by M2. So how you can calculate the value of M1 by M2? You can see, I know that if it is ideal gas, it will be equals to PV and RT. So temperature same constant, volume same, R constant, means P is directly proportional to N. So simple I can say P1 divided by P2 will be equals to N1 divided by N2. So P1 is also given, which is a 5 times that of second. Number of moles, how you can calculate? Number of moles formula I know that given mass by molecular mass. In first case, so you have helium and argon. So helium mass is M1 and molecular weight of helium plus argon M2 molecular weight of argon divided by, in second case they just change the name. So this is M2 molecular weight of helium plus M1 molecular weight of argon. Okay, so how you can solve this? You can simply solve this. Just multiply and divide it by the molecular weight of argon. If I multiply molecular weight of argon, if I divide, does any change in the equation? No. So I know that if I multiply this with this one, so molecular weight of argon and helium ratio it is given. The ratio it is given, that is equals to 10. So simple I can say it will be 10 M1 plus molecular weight of argon and argon cancel, it is equals to M2 divided by molecular weight of argon and helium that is given, that is equals to 10 of M2 plus argon cancel, that is equals to M1. You can simply solve this. How you can solve this? This is a 50 M2 plus 5 M1, that is equals to 10 M1 plus M2. Okay, so this will be equals to 10 minus 5 means 5 M1. So 50 minus 1 means 49 M2. So M1 by M2 we have to calculate, that is 49 by 5. So 49 by 5, 945 40, so it will be 9.8 will be the answer. So how simple question they ask? Let's see anything else they ask in this question. No, they just ask to calculate M1 by M2. So this is 9.8. So next, so in this case, again thermodynamics, the list contain the various physical chemical process. In list 2 contain the combination of changes in the enthalpy, entropy, the match the column. So very simple it is thermodynamics. Basic concept. Physiosorption. What is physiosorption? So physiosorption is what? If you have some let's suppose some metal surface is there, so some gas molecules are there, they get absorbed on this. So if they get absorbed means there is a formation of some bond. So if it is a formation of bond means some energy will be released. So some energy is released means delta H value will be equals to less than 0. Molecules getting adsorbed, that is a physiosorption, means entropy. So what will be the entropy? Entropy will be also less than 0. So entropy less than 0, H will be less than 0. So which option is correct? So this is the P. Okay, in case of diamond and graphite. So diamond and, okay, let me check options. So it is a P2, P2, P4 that I can cancel here. So now diamond and graphite. Graphite, I know that thermodynamically graphite is more stable. So I can say delta H will be less than that of 0. Graphite, if you know that in the case of graphite, the hybridization of carbon, that is sp2. In diamond, it is sp3. So in sp2, more freely move, so more disordered. So simple, I can say delta S is the greater than 0. So delta S greater than 0 and H less than 0. So this is option number Q. So Q will be equals to 5. So Q3, Q3, so Q5. So R1, in both case R1 is there, no need to check. So anyway, we know that denaturation of proteins. Denaturation of protein means what? That if you remember the example of boiling of egg. So denaturation of proteins, what happened in this case? In this case, boiling of egg it is. So means if you have to boil, you have to provide energy, delta H will be greater than that of 0. Or entropy, this is proteins, protein molecules getting unfolded. It will be unfolded. So means entropy will be, delta S will be greater than that of 0. So this R will be equals to 1. So now I have to check propene and cyclopropane. So propene, I know that this is a propene, this is cyclopropane. So option 3 and 4, let's check 3. In 3, see, you can see in option number 3 they have given delta S is equals to 0. So entropy not be 0. Entropy is only 0 at the absolute temperature, absolute 0 degree temperature. Third law of thermodynamics. So if you have, we know that in this case, this is a cyclic carbon. In cyclic carbon, the bond angle, if you remember, it is a 60 degree. Okay, actually bond angle it will be 120 degree. So it will be more it will be unstable. Okay. Unstable means delta H value will be greater than that of 0. So delta H value will be greater than 0. In this case, they have given delta H less than 0. So option 4 is correct. That is S. So option C will be the correct answer in this. If you have just a basic understanding, so you can able to easily answer the questions. Okay. Let's see next question. So consider, now it is organic questions. So consider the lithium borohydride reduced an ester group to corresponding alcohol and does not reduce the carboxylic acid group. See, generally they want in JEE Advanced, they will not give that much information. They generally give the reagent. You have to remember what this reagent will do what. And in this case, they give some soft corner here. They given the lithium borohydride and they say it will be reduced only ester. It will be reduced only ester group. It will not reduce to the carboxylic acid. And it will reduce this up to the alcohol. So if it is reduce this, let me see what will be the product here. Okay, means this will be converted into the alcohol. So this will be converted into the CH2OH. Okay, let me write down here also. So here you have a methyl group. At a dash position, there is a carbon double bond OH. It is a wedge here. It will be CH2 and OH. Further, if you add acid into this, I know that acid what it will do, it will remove the water. So if it remove the water, means again what it will do, if it remove the water, so I remove this OH group and it will form ester once again. Okay. Similarly, borohydrate. So borohydrate is there. We know that role of borohydrate, it is a chemoselective. Chemoselectively, it will convert the acid to alcohol. So let me write it down this way. Here it is a CH3 group. So it will be converted into alcohol OH, and there is the ester group, and there is the ester group. So this ester will be remain as it is, C double bond O, O, E, T. If you further add it into acid, so what will do? Further they will convert it into, here you have a CH3, CH2, here it is a carbon double bond oxygen, they will form ester once again. Now you can see what is the similarity and difference in the compound P and compound Q. So you can see there is two chiral center. So there are two chiral center, one it is this one, another it is this one. Here also two chiral center, 1 and 2. If I see one in both case, one chiral center is same, another it is a different, and one relation, if you remember, we know that in the case of it is a R, if it is a two chiral center will be there, R and S, RS and SR. If we draw this, what will be the relationship? They are diastereomer to each other and they are enantiomer to each other, means one same, another different. One same, another different. One same, another different. Here also one same, another different. So means what will be the relationship between? They are not identical. So they are diastereomer. P and Q are diastereomer. P and Q are diastereomer. So they are identical, wrong. They are identical, wrong. Similarly, now we can check in another case also. In other case also it is almost same. So nothing difference is there. So they have given same group here, same reagent is there. So you can draw this also. So this is here one methyl group, and at this position, okay. So let me write it down on the another page. So it is given like this. It is given like this. There is a CH. In this another case, they have given CH3 group here. So here it is a CH3 group. Here it is a C double bond O, OH. Here it is a C double bond O, OET. So if you are adding lithium borohydride, this will be converted into OH group. This will be converted into, there it is a CH3, C double bond O, this is OH, this is CH2 OH. Further, if you are adding acid what it will do? It will remove the water. So if it remove the water, so your final product will be CH3, this is a carbon double bond oxygen. Again here it is a CH2, so it will form ester like this. In this case also they have added borohydride. It is a chemoselectively reduce the ester group to reduce the acid. So what it will give? Once again, this is CH3. This will be converted into OH. This will be remain as ester. Further, if you are adding acid, this alcohol will be removed and it will give you CH3, CH2, C double bond O and ester. So again, if you can see here, You can see here, this is one chiral center, this is another chiral center. Similarly, this is one chiral center, this is another chiral center. One chiral centers are same, another are different. So what will be the relationship? So they are diastereomers to each other. They are not identicals. So they are not identical. So this is also a diastereomers to each other. So option C will be the correct answer. I hope you understand this. So next question. So this is very simple question. In the following reaction sequence, Q, R, S and T are the major product. Coal-based electrolysis. Coal-based electrolysis is given. Okay, let's start with that. So what is a coal-based electrolysis? I know that coal-based electrolysis, if I have such kind of group, C double bond O, O N A, if I do coal-based electrolysis, so it will form this R radical, another R radical, it will give me the higher alkane. So in this case also, if it is a coal-based electrolysis, we will form one radical here, one radical here. So this is one, this one, another radical, it will form hexane, 1, 2, 3, 1, 2, 3, 1, 3, 4, 5, 6. So this will become hexane. Vanadium pentoxide at higher temperature, higher pressure, what it will give? So definitely this is a method of preparation of benzene. So Q will be the benzene here. Okay. Now further you are adding this group here. So you have AlCl3. I know that what it will do. There is a lone pair of electrons. So if this is a lone pair of electrons, this is a aluminium here. Friedel-Crafts, if you remember Friedel-Crafts reaction, it will be partially negative charge here, partially positive charge here. So it will do the electrophilic substitution on the benzene. So the product form will be, there is a benzene here. This carbon double bond oxygen, benzene. So this is carbon double bond oxygen, O negative, it will take proton, it will become this. So R is here. Now further if you add PCl5, PCl5 will do what? It will convert the acid into the chloride, acid chloride, it will convert this into the acid chloride. See this. So what product it will form? This is benzene, carbon double bond oxygen, so it will become acyl chloride. So H2 palladium barium sulfate, this is what? Rosenmund. Rosenmund reduction. Rosenmund reduction, we know that acyl chloride converted into aldehyde. So you can convert this into the aldehyde. You can convert this group into aldehyde. Okay, this is benzene here. So carbon double bond oxygen, C double bond O, this is hydrogen. So this is the S. So further they treated it with the hydrazine. So NH2, NH2. So space is not there. Let me do here. So which group it is? Okay. So now this is my S here. This is C double bond O. And this is aldehyde group. So you added NH2, NH2 group. So how they will react? Okay, let me write it down in different way. So it will be nothing but benzene, carbon double bond oxygen. Here this is a phenyl group. This is a carbon double bond oxygen. This is a hydrogen. This is H2N. H2N. So what they will do? They will take water. So what it will form? This is a benzene. This is a carbon here. Phenyl group. This is nitrogen. carbon, double bond nitrogen. So there is a hydrogen. So this is my product T. Okay, all products are there. So let me read that statements. The statements about Q, R, S, T, is and are means there are multiple correct answer. So S on warming with the ammonical aluminum nitrate result in the formation of silver mirror test. What is S here? Okay, this is my S. So in S we have aldehyde group. So aldehyde group, we know that this is nothing but toluene reagent. Toluene reagent we use to detect the aldehyde. Yes, aldehyde is there. It will form the silver mirror. So option A is the correct answer. Q on the treatment with the excess of Cl2 in the presence of light give the gamma hexane. What is Q? Okay, Q is the benzene. So Q is the benzene here. So if I react this with the chlorine, we know that what it will form? BHC. Benzene hexachloride. So what are the another name of benzene hexachloride? Gamma hexane. Benzene hexachloride, 6. Benzene hexachloride also you can say. Landane also you can say. There are so many names of this gamma hexane, means B is also correct. So T is the heterocyclic compound. Where is my T? Okay, T is in another page. So this is a T. Is it heterocyclic? Yes, it is a heterocyclic compound. So means option number C is also correct. R. Now they are saying R on the acid catalyze the intramolecular cyclization, follow the treatment with the zinc, mercury and HCl. So what is R here? This one. Okay, let me draw this here. So let me write it down. Let me write down here only. If I do the cyclization of this, so what it will be? If I do the cyclization, it will be the benzene C double bond O. Here also C double bond O. This is again benzene. Further, if you will add zinc mercury, I know that zinc, what zinc will do? Zinc will be reduce this up to the alkane. It will reduce this up to alkane, but they are saying it will form the 9,10 dihydrohexane anthracene, means there is no chance of left the hydroxy group. So hydroxy group will not left, it will be converted into CH2. So means option D is the incorrect answer. So option A, B, C is the correct answer. Next, okay, this is a very simple question. The sum of total number of carbonyl groups present in the major product X and Y following reaction. So what it is given here? Okay, one thing we know that beta keto acid, if you heat this, what it will give? CO2 will be liberate. So this is nothing but this is alpha beta. So beta keto acid means CO2 will be removed. What it will give? H3 carbon double bond oxygen. This is a CH3. Okay. In this case, this is alpha, this is beta, this is gamma. This is not a beta keto acid. So what we'll do? If you are heating this, this is double bond O, this is a C double bond O, water will be removed. So it will form this product. If water is removed from this hydrogen and water will be removed. So what they are saying, sum of total number of carbonyl group. In this case, how many carbonyl group? 1, 2, 3. So 1 plus 3 will be equals to, there are total 4 carbonyl group. Simple question was there. Next, the treatment of buta-1,3-diene with the sodamide, 2 equivalents are there. Okay, followed by the reaction with the excess of this alkyl halide group. It is given X as a major product, the maximum number of carbon atom that are in the co-linear or in the state. Okay, let's see what it is given. Buta 1,3-diwines. So this is the carbon 1, 2, 3 single bond, carbon 1, 2, 3 carbon. This is the hydrogen. Hydrogen, if you are reacting with the NaNH2. So what is this? This is a base. This is act as acid. It will be acid-base reaction. So what it will form? Carbon, triple bond, carbon, triple bond, carbon. This is Na. This is Na. Excess of alkyl halide you have added. If I am saying this is RBr, if it is an excess, this is the positive, negative, negative, positive. This negative will be attack on this. This Br2 will be out because it is an excess. Means from both side it will be happen same. So negative charge will be here. This Br group will be go out. So R group they have given R is equals to trans. So this is CH double bond CH. This is CH2 Br. This is CH3. Okay, let me write it down this way. So this is nothing but this is a carbon, triple bond, carbon, again carbon, triple bond, carbon, 1, 2, 3, 4. So here CH group, CH2. This is a CH double bond CH. Here nothing but this is a CH3 because it is a trans. Again in this side also this is a CH2. This is a CH double bond CH. This is CH2 because it is a trans. Okay, then count. Here how many carbons are in collinear? We know that this is a sp hybridized. This is also sp hybridized. Sp hybridized means bond angle will be here 180, 180. Here also it is 180. Here also 180. 180 bond angle. Okay. So means, so in this case means this one it is a 1, 2, 3, 4, 5, 6. Total how many carbons are in the same line? So total 6 carbons are in the collinear or in the straight line. So it was a very simple question. So next question. Okay, this is again this question from the organic. List 2 contain the product obtained from the reactions of the compound in list 1 with the O3 ozonolysis in the presence of zinc, followed by the cyclization via most stable enolate. Means there will be some enolate in the presence of aqueous NaOH. Match each entry. See, if you have basic understanding of the general organic chemistry or organic chemistry simple, you can solve this question in the 30 seconds. Because I know that it is a enolate. Enolate further follow up by the you are adding NaOH. When you have enolate, you are adding NaOH. What reaction it is? It is aldol. It is aldol reaction. It is aldol reaction, not aldol condensation. It is only aldol reaction. I know that if it is aldol reaction, what it will form? Product of aldol reaction is what? Beta hydroxy aldehyde or ketone. It depends upon the group present there. You can simply see they are saying every reaction following the same process via the enolate, the presence of NaOH. Means there should be a beta hydroxy keto group. So you can see this is a keto, this is alpha, this is a beta. Okay, alpha, this is a beta. Correct. This is alpha, this is beta. One second. So let me erase this. Let me write down once again. So this is alpha position, this is beta. Yes, it is beta hydroxy. In this case, you can see hydroxy group is present at the alpha position. In this case, this is alpha, this is a beta. So hydroxy group is present at. So this is not possible at alpha position. Hydroxy group is not possible. Just see Q4 means not, Q4 not, R4 not, means option C is the correct. So within 30 seconds, you can answer the question. Okay, I will explain this in detail also. So in this case, so what they are saying, you can see this, one. So in this case, okay, let me write down on the another page. So this is the first, this is CH3, this is another CH3. So first, if it is a ozonolysis, I know that it will be break from here. So it will be break from here, it will form double bond O, double bond O. Okay. Now further you are adding base. NaOH, aqueous NaOH, you are adding base properties. What? It will obstruct the proton. So from the general understanding, from which side you will obstruct the proton? Obviously there is one hydrogen here and one hydrogen here. If you obstruct the proton from here, it will form carbonyl here. If you obstruct the proton from here, it will form the carbonyl here. Ideally, this is the 3 degree carbonyl which is unstable as compared to 2 degree. It should prefer the 2 degree. But what we can do, they have mentioned already. This reaction is followed by the cyclization via the more stable enolate. So more stable enolate means what? Means enolate should be the more stable. So we know that according to Sarat rule, which alkene is more stable, which is more substituted. So if you remove the H positive ion from here, so it will form the more substituted alkene, which is more stable. So what will happen here? So in this case, this negative charge further will be attack on this. This negative charge will be attack on this. Or this double bond will be break. Now you can see, count this. This is 1, 2, 3, 4, 5. Means one it is a 5-member ring, another it is a 7-member ring. So let me write it down this way. This is a 5-member ring. 1, 2, 3, 4, 5. So this is a 7-member ring. Okay. At position number 1, there is a CH3 group. Okay. At position number 5, there is OH group. Next to this, this is a double bond O. Next to this, this is a CH3. So now match this. Which option is correct? CH3. You can see here. You can see. You can see. This is the CH3 group and OH group. Along with OH group, there is methyl group, and keto group. This is the same. Methyl group, keto group, OH group, methyl group. So option 2 is for the P. Similarly, you can do for this one also. You can do for this one also. I can write it down here again, once again. So here, so what it is given? 7-member ring, double bond and methyl group. So this is 1, 2, 3, 4, 5. 7-member ring. This is 5-member ring. Here it is a CH3 group. Here it is also a CH3 group. So in this case again, ozonolysis, this bond will be break. It will be double bond O. It will be double bond O here. Again, I can abstract now again. I can abstract hydrogen from here also. I can abstract hydrogen from this side also. But I know that if I abstract the hydrogen from this, it will form 4-member ring. So none of the option is there with the 4-member ring. So definitely it will abstract the proton from this. So here it is a negatively charged. So this negative charge further attack on this. It will form 1, 2, 3, 4, 5, 6-member ring. So it will form the 6-member ring. 2 6-member rings are there. So here are the 2 6-member ring. At first position there is a methyl group. At sixth position, so this will be break, it will become OH group. So at this position you have a CH3 group. So at this position you have a double bond. So you can see once again, six membering methyl, keto, methyl, OH. Six membering methyl, keto, methyl, OH. So Q is equals to 1. Same way you can calculate for the other. Exactly same pathway you have to follow. You will come to the answer number C. Now, let me try to solve this question. I hope you can able to see this. In this case, first reaction was there P. So P is there. Let me write down the P. Nitro group, benzene, bromine. Okay. So here it is. Nitro group. This is Br here. Okay. This is carbon double bond nitrogen. This is OH here. Here I have a hydrogen. If I add base into this, if I am adding base, I know that base will obstruct the proton. This is negatively charged. This is electron withdrawing group. So this negative will be attack on this. Br will be go out. So first product it will be formed like this. It is NO2, carbon double bond nitrogen, oxygen, like this. This is a hydrogen here. We know that it is a strong base. It will obstruct this one proton also. So it is a negative charge will become here. This will be break. So it will lead to give you the product like this. This is NO2 group. This is a carbon triple bond nitrogen. This is the OH. Okay. Let's see which product it is. At para position OH group, meta position cyanide. Para position OH group, meta position cyanide. So P is equals to 1. P is equals to 1. P is equals to 1. So Q2 need not to check. We can check R because in both case Q it is a 2 or 2 only. So let's check for R. So in case of R, you can see R and P both are same. R and P are same, but in this case there is a hydrogen. Here it is a methyl group. If there is a hydrogen only, see, if there is a methyl group, I am writing this once again. Means now this is a carbon double bond nitrogen. This is oxygen. So here it is a methyl group and here it is a nitro. Means this reaction will be stopped here only. Further you don't have any proton, so it will obstruct the proton. So it will be stopped here only. So this will be the product. You can see. So okay. So for R, this is the product same as that of R. So R is equals to 4. This is the wrong answer. So option B is the correct. You can check for S also. It is S. S group it is. I know that in the presence of aqueous, this is a base. What it will do? It will break down like this. So this group will be break and this group will be break and it will give. This is a NO2. This is a carbon nitrogen. It will form OH and CH3, which is a correct as that of 5. The option number B is the correct answer. Next question. Okay, so this is a question from the inorganic. So this is a very basic question. Every year they ask the question from this, the comparison of the dipole moment of NH3 and NF3. Every year they ask in JEE Main. This year also they asked. Next year also they will ask. See, NF3 and NH3. Which one has more dipole moment? I know that nitrogen, hydrogen, hydrogen and hydrogen. One lone pair is there. Similarly, in case of NF, this is a fluorine, fluorine, fluorine. One lone pair is there. So what is the direction of dipole moment? In this case, it will be toward the direction of lone pair. This is opposite. So if you see in this case upward, this is nitrogen is more electronactive as compared to hydrogen. All are in the same direction. So dipole moment of NH3 is greater than that of NF3. NH3 is greater than that of NH3. NH3 greater than that of NF3 is greater than wrong. NF3 is greater than wrong answer. Okay. Let me compare BF3 and NH4. So BF3, I know that it is a symmetrical sp2 hybridization. Fluorine for symmetrical molecule, dipole moment 0. NH4 again 4 sigma bonds, steric number 4, sp3 symmetrical, dipole moment 0. They both having same. So this is a wrong. Option 1, it is a correct answer. So this question this question is directly from the NCERT book. NCERT book chapter P block element. So see what they people did. Nothing changed. There is nothing changed. Exactly same wording they use. The sterilization of drinking water, enrichment of uranium, same as it is. The wording is mentioned in the NCERT book. If you read this properly, you can see. So what they have done in this question, MnO2, it is react with the concentrated HCl, and it give MnCl2 plus greenish yellow gas. We know that this is a process, nothing for. This is just for the method of preparation of chlorine gas. So what it will form here? Cl2. I know that Cl2 color is greenish yellow color. When this Cl2 react with excess of Cl2 react with NH3, it will give NCl3 plus HCl. Further, this Cl2 react with F2, it will give ClF3. So now let's read the question. So the correct statement about the compound XYZ is and are, means there are multiple answer question is there. So X is used for the sterilization of drinking water. Yes. Y is the planar structure. Y, it is NaCl. NCl3. So steric number Q plus R by 2, sigma bond 3, R, number of non-bonded electrons 2 will be equals to 1. So that is sp3. sp3 means this is not a planar, this is trigonal pyramidal. So option B is incorrect. Z is used in the enrichment of uranium-235. Yes, this is the ClF3 used for the uranium enrichment 235. It will give uranium F6. This is as it is reaction, as it is wording they have given in the NCERT book. Similarly, Y is the stronger Lewis base than ammonia. Y is what? Okay, ammonia is, let me compare this with the ammonia. This is NH3, Lewis base, which can donate the electron. It can donate electron, it can also donate the electron, but there is a chlorine electron-active group. It is not donate easily as compared to NH3 group. So why is the Lewis base stronger? Not. So option A and C is the correct answer. So next, so reaction of PtF6, this is a PtF6 with the O2. It gives the formation of ionic product X positive and Y negative. X positive means this is a O2 positive, this is a PtF6 negative. Okay, the correct statement is and are, means multiple correct answers are there. So bond order of X positive is 1.5. So O2 positive, what is the bond order? I know that O2 bond order it is 2, means this is a 16 electrons, in this case 15 electrons. So bond order will be equals to 2.5. So option A is incorrect. Valence d orbitals of metal ion in the X positive and Y negative has the 5 electrons. So valence d electron of metal. So what is metal here? Platinum F6 negative. So what is the oxidation state? It will be platinum plus 5. So platinum, electronic configuration platinum, it is a nickel platinum, that is nothing but helium neon neon one second, let me use eraser here. So this is nothing but this is a 3D8 4s2, means platinum will be, this is a 4D and this is a 5s, this is a 6s, this is a 6s, this is a 5D, this is a 5D9, 6s to 4f14 for the platinum. Okay, so plus 5, remove 5 electron, means it is a 4f14, 1 electrons, this is a 6s1 actually. So 6s1, so 1 electron it is removed from the s, 4 electron will be go from here, so this is 5d5, so 5d5, what they say, valence d orbital of metal has a plus 5 electron, so option B is the correct answer. So platinum F6 act as an oxidant. Oxidant is what? What are the oxidant? Which means oxidizing agent. Oxidizing agent means which reduce itself and oxidize other. You can see platinum, it convert into platinum F negative, means it take electron, it reduce itself and it take the electron from the oxygen. So it oxidize the oxygen. Yes, platinum act as an oxidizing agent in the reaction. So platinum F6 act as a fluorinating agent in the reaction. Fluorinating agent means will this give the fluorine? No, it is not giving the fluorine at any step of the reaction. So it is not act as a fluorinating agent in this reaction. So option B and C is the correct option. Next. So total number of all possible isomers for the square planar complex with the formula given. Okay. So this is the same question they had given in the JEE Main, this year JEE Main only. So only small changes there. Instead of glycine, they have put fluorine and chlorine. Okay, let me take this. Okay, let me take, this is a metal. This is the NCS. This is NO2 group, and this is a glycine. Okay. So let's see how many linkage isomers are possible. I know that this is also linkage metal. I can keep NCS as it is. Nitro group I can link it with the oxygen. So this is a glycine. One linkage isomer is this one possible. Another way, in this case, it can be linked as SCN and ONO and glycine. Another MSCN, NO2 and glycine. 4 linkage isomers are possible. So 4 linkage isomer possible. So let me check one linkage isomer. So this is a square planar only. This is a central metal. So glycine. So glycine linkage, one it is oxygen, one it is nitrogen. So one side if it is a NCS, another side it is a NO2 group. So another possibility is what? This is a metal, oxygen, nitrogen. Here it is NO2 group. Here it is NCS. So means with respect to one linkage isomer, 2 geometrical isomers are possible. So total 4 linkages with respect to 4 into 2. Total how many isomers are possible? So answer will be the 8. Simple question it is. This is a repeated question. Next. Okay. In this case, you have to list one contain the different molecular shape. Okay. And list 2 contain total number of species with the same molecular shape, form, shape. Okay, molecular shape you have to tell. Match each entry with the approximate entry of. Okay. Okay, so what it is given? SOCl2. So SOCl2. So 6 electrons sulfur has means 1 lone pair of electrons. I know the formula of steric number. How to calculate steric number is equals to Q plus R by 2. How many sigma bond? 3, 1 lone pair of electron, that is equals to 4. So it is sp3 hybridized 1 lone pair of electron, means this is a trigonal pyramidal. So it is trigonal pyramidal. So next, xenon double bond O, 4 fluorines are there, total 8 electrons. Xenon has 1, 2, 3, 4, 5, 6 and 1 lone pair of electrons. So steric number, sigma bonds are there 5, 1 lone pair of electron, that is 6. So it will be sp3d2, means octahedral geometry, 1 lone pair, then shape will be equals to square planar. Okay, ClF3. So ClF3 I am writing here, ClF3 1, 2, 3 means 7 lone pairs, 7 electrons around fluorines. 3 fluorines are there, means 2 lone pairs of electron, 3 sigma bond plus 2 non-bonding electron, 5, means it is a trigonal bipyramidal. So 2 lone pair of electron means it is a T shape. Okay, this is the T shape here. Okay, this one ClF3 and xenon F3 positive, both are same, means if this is T shape, this is also T shape, because chlorine has 7 electrons, xenon has 8, but 1 positive charge is there, means it also having the 7 electrons. 3 fluorine groups are there, this is also T shapes, any other T shape, so means T shapes only 2. So T shape only 2. SF4, let me check for SF4. SF4 means 6 electron, 1 lone pair of electrons will be there, sigma bond 4, 1 lone pair of electron, it is 5. 5 means sp3d. So sp3d means trigonal bipyramidal, 1 lone pair of electron, means shape will be equals to seesaw. So seesaw, it is only 1. Seesaw, it is only 1. So what left? This one, ClF5. Okay, let me write down ClF5. So total 7 electron, means 1 lone pair of electrons will be there. So 5 sigma bond, 1 non-bonded electrons, 1 lone pair of electron will be equals to 6 sp3d2. sp3d2 means octahedral geometry, then shape means 1 lone pair of electron. So during the shape we have to ignore lone pairs of electrons, so that it is a square pyramidal. Okay, this is also square pyramidal. If this is square pyramidal, so this one is also square pyramidal. This is a xenon F5 positive, so both are square pyramidal. I'm writing here ClF5 and xenon F5, both are same. One more square pyramidal I have check here, xenon O F4. So 3 square pyramidals are there. Okay, trigonal planar, what left? So we are left with SO3 2 negative. So SO3 2 negative means S double bond O. This is O negative negative, total 4, 1 lone pair of electrons, 3 sigma bond plus 1, that is equals to 4 sp3. So if it is sp3 means 1 lone pair of electron, means it is a trigonal pyramidals. So it is given trigonal planar. So none of that is a trigonal planar. So trigonal planar, it is a 0, means R is equals to 5, P is equals to 1, P is equals to 1. This is cancel. Q is equals to 2, Q is equals to 2, this is also cancel. So another option we are left with R5. Yes, it is 0. S, it is a 3. Yes, it is a 3. So option A is the correct answer. Next. Okay, that's all. So this is all about the paper 1.